In this video, we're going to take a look at something called leads. So leads basically mean that the tool plunges into the material outside of the shape and then comes in to cut the actual shape that you want. So I'll show you how to use that. So if we open up the profile toolpath that I've created, just turn off my bridges that I have selected, and you have a section called Add Lead In, Lead Out Moves. So if I tick that, I'll just move that over so you can see this. And this gives me quite a few options when I select it. Now you have two different options. You have linear, so it's going to do a straight move into the material or into the finishing cut, or a circular, so it will do a circular arc going into the cut. Now the reason that you would do this is maybe to avoid chipping when the tool plunges into the material, or maybe a scorch mark or a little discrepancy where the tool plunges into the material. It can create a little bit of a cusp. Okay, so to use this, just going to turn off lead out. So it says do not lead out, so I'm going to turn that off for a moment. The distance, I'll do this as 1 inch, and I'm doing it at 45 degrees. Okay, so calculate, and then what this does, it comes in at 45 degrees, cuts the part out, and then comes out. Okay. So if I were to simulate this, you can see it's coming in at 45, it's cutting the part out and coming back to there. Now you'll notice that this is overriding my start point. So if I delete that and I'll just simulate it with a control bar, you notice that this is overriding my start point, which is here. So let's sort that out first of all. So to do that, turn off automatic positioning. So if I calculate it now, it works on the start point. Okay. The distance obviously is how far away it plunges. So if I were to make that 2 inches and calculate, it comes over 2 inches and then comes in at 45. So if I were to make that again 1 inch, but maybe the angle, I make it so less drastic, and have it at 15 degrees, and then it comes in at 15 degrees. Now we can also add a lead out. So if I untick that, it will lead out as well. So if I calculate that, it will go in, machine the part, and then come out. Okay. I can also overcut. So if I were to overcut by 1 inch and calculate that, then what happens is it leads in, cuts the part out, and then comes round to here and then comes out. So this is useful if you've got a little cusp on the lead in for machining. So I'll set that back to 0 and calculate it. Okay. Now normally I don't really use overcut, to be completely honest, and I don't use a linear. What I tend to use is a circular arc. So if I were to set that up as, let's say, 1 inch radius and calculate, what this does, it creates a circular arc, comes in, then cuts the part out, and then comes back out using a circular arc. Now that's probably a little bit high. So let's change that to be 1/4 inch. Now what this is telling me is that the lead in that I've created, the distance is too large for this radius. Okay, so it's saying that the distance needs to be less than the radius. So let's make the distance, let's say 0.2, and calculate. And there you can see it creates this lead for me. Now if you wanted it to be less drastic than this, then create a large radius. So let's say that I wanted this to be 10 inches. okay? And then it would smoothly go into the material, cut the part out, and then smoothly come out of there. Now, the reason that I like using circular arcs like this is because it doesn't change direction on the CNC machine. So if I were to go back to creating a linear, let's put it back to 1 inch and 45 and calculate. What happens here is that it will come down and then it has to change direction. So for a split second, it will stop and then it needs to accelerate back up to speed. So that's the whole reason that I don't like doing that, because you can still get chipping on the edge if you were to do that. So that's how you add lead in and lead out moves, and that's what they're for.